Okay, let's jump to the component. So before jump to component, I would like to see this kind of the article. Yeah, I can click this article. Yeah. So meantime, okay, we have a component folder here, right? So just double click the first example. Oh, they ask me to either save or not because I added a cube, but I don't want to save, so I click don't save. Okay, so I click this component parameter, right? And I'm executing. I'm basically open the scene file, which contain multiple configure a file or geometry or game object or whatever things, and I can click the play button, right? Basically, it parses all my C# code and then execute it. As you can see here, the sphere colors turn to the red color, right? Yeah, and then we can see some other information just like it, right? And then you can click the same name but a different extension name called C#. You can double click it, and then it automatically opens the Visual Studio Code on my case. Yeah, maybe Unity can trigger some or Visual Studio community to your environment, but I just bind the Visual Studio Code with the Unity, so I can see this kind of the window. And here's the class diagram in Unity. I'm also press by control left mouse click. So there are many ways of looking at the Unity. Yeah. So, but I always mention this kind of component-centric programming or component-centric, let's say, programming. Yeah. So there are different types of a paradigm, maybe, but what I'm trying to say is that by understanding, I don't like this tab. So there are many ways to understand the Unity, but this kind of the perspective is important to digest and understanding the fundamental the system of the Unity. So Unity is let's say you can component-centric program. Unity has the game object, which is sort of a wrapper. Yeah. When I say wrapper they potentially become parent. It has a lot of children as a component. So we have a mesh render component, mesh filter component, the transform component, individual component we can attach or detach, right, if necessary. So again, so the mesh the component has a potentially can have the other component as a children. It's like a hierarchy. So game object is let's say one of the basic or essential wrapper, and then we have a transform and box collider for rigid body for the physics simulation, things like that. So if you guys are more interested in or understanding more, then I can share this article, in our oops, I lose. Okay, in our Medium page, it has a link. Yeah. But I think this is enough to understand this diagram, right? It's nothing special. We have a game object. Again, it has a parameter, yeah, and also function, yeah. If you studied the C# has a class, and class has like a variable and execution. The function variable is usually something like height or weight of people, and the function is indicating like some action, like a work or digest or talk, things like that. So we can encapsulate these two things in one class. We can call it as a component in the Unity environment. And then component can have the other component as a children. So we have a reciprocal relationship or children-parent relationships, okay? So here, also Unity has the other concept like the start and updates, yeah, but we will see the update later. But start is the function, that's gonna execute one time when you click the play button here. Yeah. So this is the minimum C# code for the one Unity component, right? So the Unity has, as I said, like it has some parameter, right? Which is like weight or height or people, for example. We can store some information, right? On the other hand, we have a function that is execute something like a work, talk, digest, which describes some behavior, right? So using this component, we can access this component, the context. So this basically indicates this component. In this case, I can double click my component here. Okay, clear. Yeah, so I have a my sphere, right? My sphere has this script because I just simply drag and drop. Yeah, I can simply drag and drop. Okay. Remove other things. So now we know this my sphere has this script, right? So this name is basically indicates this name, my sphere, because we attach this script to this game object. Am I right? Yeah. So this game object also contains the transform, right? And mesh filter and mesh renderer and collider and script. The script is also one of the component. Now we know, right? This is game object. It contains this kind of component individually. So just like that, we have a game component, mesh filter, mesh renderer, transform. Actually, we append another component as a custom component that we built in the C#, right? This like a component one parameter. This is act as a component. Yeah, you guys can make some mental map, right? Mental structure of the Unity. I'm trying to help you. So now this is this indicating the sphere, right? And also I'm gonna access the transform. Yeah, transform and then position or local scale. So for example, this is sphere transform position to string is I want to print this information in the console log. Yeah. So my sphere, we have a transform. The positions x 1 and -1 along the y and the z for 0, right? So if I hit the play button, we can go all the way up. Yeah, this is the position, right? Position 1, -1, 0. The name is my sphere because it's my sphere, right? So, okay, here. So now we know how to access and print information on the console log. So this is a way to get them a component. So this, as I said, this is the sphere in this case, right? So sphere has a mesh filter here. So what if we wanted to access like a graph, like get the mesh filter to access other parameter, right? So we have the get component in built-in function, yeah. So this is a syntax, just follow. We need to just follow this get component. You can put the name of the component. Maybe you can do the transform, yeah. Or we wanted to do mesh filters in this case, right? So this means that, oops, sorry. Where are you? Okay. This means that this mesh component, yeah, this mesh component. And then I store this information MF. The mesh component has a mesh and vertices. It's like we can drill down sphere, mesh filter, vertices, mesh filter, mesh, and vertices. Let's take a look at the diagram again. We have a mesh filter, okay? But there's no particular information. But however, if you install correctly, I can type in MF. If you press the dot and then you can see all the parameter with the function. Yeah. So now we can see here mesh right here. Also, you can put another dot. We have a bunch of variable and functions. Yeah, this is all information we can cook. Yeah. Don't worry about to memorize everything. Even I have no idea. Whenever I wanted to make some algorithm, I always search, Google it, because we have no idea. There's a good documentation and good API on the online. So I will show you how to search whenever you have question later. So anyhow, we passed all the vertices. Vertices is basically set of vectors, right? So I'm gonna print how many vertices the mesh have here. And then throughout the for loop, I can individually visit the individual vertices and then print the information. Later, I'm also wanted to get the renderer, because throughout the renderer, we can access the material in order to change the color of the sphere, just like that. So there's a reference, you can click it, you can see more information here. Anyhow, so these are sort of a fashion to graph the fetch the renderer component and then update the color by material function. So here, click to play, execute the C# component. And then now you can see here, right? This is the tag is untagged here. Okay, we successfully printed this parameter. And then also I can successfully print the name of the sphere. Yeah. And this is transform, this position, the local scale 1, 1, 1. It makes sense, right? If I put the local scale 2, we can have like a little scale sphere here, right? And everything's okay. The total number of vertices is 550. Yeah. And then this print individual position of the vertices. Yeah, there's a lot, 500, I guess. All the way down, and you can see the color RGBA. R means red, green, blue, A means alpha. The maximum value is number 1. This is a normalized value between 0 and 1, right? But in the Photoshop and the CSS, people use the 0 to 555 for the color, but Unity environment, we use the 1 for red color. Okay, so these are simple example, how we access and pass the information, print it or execute it, the parameter. Any question? Okay. Yeah, so let's jump to the second example, attach components. Just double click, don't save, and then clear the console window. And then I'm going to click the play button. You can see, what is this? Ooh, yeah. We have a ground, and we have other cylinder, circle, rectangle, cube. There are some geometry, and then this cube is moving automatically by pushing this cylinder, and cylinder is far down from ground. Yeah. Okay, what's happening? So we have a main game object. Main game object sort of an entry. Actually, main is like an empty object. So you can click the right button, just click create the empty object. It's nothing special, just like that, which has a very minimum code. And then I click this, I create this C# component and then attach this code to here, just like that. This is my purpose. So there are many ways. Some people create the game object, and then people also create the C# script for individual game object, which is good, but sometimes which is complicated because we have no idea. It's really hard to track the individual C# code. So in this case, I create the one C# component that they control all other game objects. It's easy to memorize or easy to manage. So let's jump to click this C# file here. So when you execute the main file, this file gonna execute. Okay, the start is just one-time operation. Whenever you play, this is just doing one time, and then update is the as time goes by, we regularly update. Yeah. The reason why we separate them is because there are many reasons. One reason, I guess, is performance reason, because sometimes we wanted to just calculate one time. Yeah, that's it. But sometimes we need to continuously compute to update based on the every frame. In this case, we can put the algorithm inside of the update function. Otherwise, we can put the start. Yeah. So game object is the class provided by the Unity technology group. Yeah, and then they have the static function to create the primitive. If you click this document, you can see some example. Yeah, just like that. You can just follow it, right? So there's some enumerator. You can put what kind of geometry you wanted to create, right? There's some primitive shapes, right? And then I'm not going to talk about the C# things because we have a limited time. So it has a return value, right? Return value is a game object. So that's why I put the game object. So we can create the plane, cube, sphere, capsule, cylinder, right? So particularly in the cylinder, so I'm trying to access the transform and position, just like that. Game object, transform, and the transform has a position, right? So it has a component, wrapper, it has the other component. This component has a variable, right? So I'm trying to access this position and then create a new vector. Basically, I'm trying to reposition the cylinder, okay? So I create a new vector and then assign the vector, basically override the transforms vector, yeah? And also, I can grab the renderer, yeah, and then access the material and color, and then we can do the blue. Otherwise, we can create our new color, like zero. This is green, this is blue, this is alpha, yeah, just like that. The same practice. However, we wanted to stick to this one, and you can see any other color, blue. That's it. And also, transform has not only position value, but also it has a function for the rotation. Yeah. So we have a vector, and then this is indicating axis. This is the degree. Yeah. And also, I would like to add the rigid body to the cylinder. Yeah. So if you use the add component, it's basically not only add the rigid body component, but also it return the component so that we can update the mesh, and also later we can update the collision anyhow. So we have a cube here, right? And then also append the rigid body. So this is actually identical operation, just like that. So I can create the game object cube, right? Here's a cube, and also I need to I wanted to update the rigid body. So I just did the manually, but we don't want, because we wanted to make a procedural sort of pipeline. So if you hit the play button, yeah, now we create the individual object. However, there's a cube. A cube has the rigid body, and cube's color is different, right? And also we have cylinder here. Cylinder has a rigid body and color. That's why we can apply some collision test. Yeah. Because I'm keep pushing the yellow box on the left side along the x-axis. Here we have an update, right? So this cube's position is, I move the position, basically the cube along the x-axis. So individual frame, we update this much value for that things, and also change the color. So that's why we can see this kind of animation. See? Okay, great. We can speed up a little bit. Don't save. The transform update. Click it. Just play it. Ooh, yeah, we have a cube which rotating while oscillating. Yeah. Let's double click this C# file and see what's going on. Yeah, we have a basic fashion. We have a start function and update function. And I also declare one variable out of this scope, but actually inside of this scope, meaning that the cube is become global variable that we can access in any place in this class, which is important. So I basically found my object and then save this data, game object, to that variable, and then try to print the tag and then position of this cube. That's it. And then I a little exaggerate the scale, like a squeeze along the x-axis. Yeah, this is the happening for the for one time when the geometry created. Okay, and then this is the update function. So every frame we're gonna execute. So we basically increment the time value, right? And then update the position. The position is along the x-axis, we can keep accumulate this number, and using the cosine, we can make an oscillate animation. Yeah, we can play. You can play with the number by tweaking or mesh around the number. And then we also apply the rotation and then console the time for every frame. That's it. So play. The main object has this script, and then inside of the script, as we already read, right? It tried to grab this my cube, right? So my cube is tag is untagged and name is my cube. You can go up all the way top here. The tag is untagged, right? Untagged. And then this is the first position, but the position is continuously updated, so the number gonna be different, right? And this is the time, right? We increase 0.1, right? And then they working, animating like that based on the code that we wrote in the update. So for example, we can do just like that. Y, Z axis, we don't care, but we want to update the along the x axis. No rotation. And then play it. The cube gonna go to along the x direction. Go, yeah, x direction. Can you see this? Oh, by the way, the coordinate system is a little bit different than those who are familiar with the 3ds Max Maya or Rhino, because it has an x-axis is this direction, and then z direction is actually y direction, as opposed to the Rhino or 3ds Max. And then this direction is a z and y direction. Yeah.
Does anybody know why that logic is applied? Because this is not just Unity specific, right? So you have the same, let's say, in Blender. So there's a couple of other programs that the Y and Z are flipped. Any idea why this is done?
This is the Z direction. Just for you.
So if you think about a program like Rhino, which is creating Euclidean geometry, so you have your XY plane and your depth is Z, right? So then it makes sense for you to do that. Versus when we're looking at animation-based or game-based environments, if you think about your plane being your eyes, right, your screen, so then therefore your X and Y is your screen, and depth is then what is you're seeing through, right? So therefore the Y and Z flipping is always based on how information is being perceived. So this is an interesting kind of way that these programs are set up. So therefore, in Unity, automatically your Y is Z. So when you're importing and exporting geometry, so for instance, when you're doing FBX export or import from Rhino, it's gonna have an option to flip Y and Z, right? But this idea of depth being perceived as a different thing, whether this is a program for modeling versus viewing or interaction, is quite interesting. It's the side note.
Great, thank you for the information, and you can jump to other examples.
May I ask a question in
Sure.
this script?
Yep. Yes.
Yeah. So here in line 25, you write like this time plus equal this interval time. What is the difference between this and time data time?
Oh yeah. Okay. So delta time is a sort of inbuilt class provided by Unity. But the time is I just make a manually. I mean, it has nothing to do with delta time because I wanted to keep track like the increment based on the frame. Basically, you can consider this one as to track the the number of frames that you play. Okay, so for example, like interval is going to number 1. If you play it, because every frame we can calculate the render this update function so that we can basically track the frame rate basically. So in this case, the time is a frame rate, okay? But the delta time is a little bit different. The delta time is, let's say, there are many ways to see the delta time, but think about it, like a computer has a different performance, or network condition is also sometimes is no good, right? So we can play a game, for example, right? I shoot the missile to my enemy, right? But my computer is enough faster to play the 30 frames per second, for example. But my co-player, my friends, the computer for some reason is not that great, so that they had to, sometimes the frame rate is become reduced, like a 50 or 20 frames per second, for example. So in this case, we make sure the distance the missile move, regardless of the time frame. Does it make sense, right? So in this case, people can use the delta time to like interpolate the missing distance, because if you have a faster computer, you can compute quickly. But if your computer is no good, then you need to offset some distance because you're missing some frames to compute, right? So in this case, I guess the delta time is pretty important to synchronize the different devices throughout the internet or online. But I guess the data visualization or like the interaction, just like we did for the design purpose or some visualization purpose, I think the delta time, you can use it, yeah. So, but I would like to track the frame directly, so that's why I prefer using the time that I create as a custom value.
So the data time is influenced by each computer's FPS?
Yeah, yeah. The time
this one is not.
Yeah, this is my understanding of that. Yeah.
Thank you.
So sometimes when you're working with VR headset, and let's say that you're doing an experiment where in addition to the VR headset, you have, let's say, a sensor that's tracking your heartbeat and your eye gaze and other things, right? So these are hardware that each of them, they have their slight like millisecond delays. And so often for you to kind of synchronize the timing, that becomes one of the most challenging components. So coming up with a way that either you're using your machine's time, or you're using frame rate, or you're using your time as a variable, it becomes a way to coordinate kind of these stamps that eventually you need to be matching.
Cool. Yeah. Thank you for the question. Yeah, and you can jump to next example. So this is the example of how we duplicate the geometry and then remove the geometry. So as time goes by, I can create the the cylinder in order, And once we reach certain number of the cylinder, then we can destroy the cylinder in order. That's it. Simple, right? So click the main game object. We have this script. Just double click it to jump to the Visual Studio Code. Here, yeah, so once we declare the variable in that scope, meaning that we want to use this variable in a global scope so that we can access not only from this function, but also this function. So here, this is the sum of the algorithm. Then increase the time like 1. Yeah, just track the frame, for example. If the frame is bigger than 60 frames, like after 2 seconds, for example, and then we try to, if this is true, obviously this is true. If this is true, then we can duplicate, basically by using the instantiate function, we basically duplicate the game object, and then I reposition differently, and then add this game object in this array, because once we finish this function, we wanted to destroy again. Yeah. So once reach certain amount of a certain number of the cylinder that we create, and we switch this if state conditional state, so that we are able to execute this line of codes, right? So in this case, if the condition is met, then this JS is the list that we saved in that scope, right? It's gonna contain all the cylinder, and then we want to remove the first item in that list. Yeah, that's it. This is more about like a C#, let's say, index, remove things like that. But the only Unity specific thing is this static function and this static function. By doing utilize instantiation and destroy, we can duplicate the game object. Otherwise, you can remove the game object. This is the lesson from this example. Send the message is nothing special, but just good to know. Yeah. Okay. There's some error. I don't know. You can see what is the error. Okay. So basically, the send message is a function to trigger execute the other function that belongs to other geometry. So for example, this is the function that we wanted to call print name, right? So, okay. So we have a cube, right? And cylinder and sphere. So each game object has this code, this component. Yeah. So meaning that each object potentially execute this function, right? However, the function gonna be triggered by from this code. From this code. Yeah, this is the key. So look at me on the screen. So we have 3 game objects here, right? 3 game objects here. This is main, which is not, this is looks like game object, but it has no sort of geometry, whatever. This is just like an entry point for programming. So we have 3 actual geometry, and then this from this main component, we can ask individual geometry or game object to execute something. This is the idea behind the scene. Okay, so now we can print like cube, cylinder, sphere, because we ask them to print their name: cube, cylinder, sphere. Oops. Okay. Yeah, sorry. So again, individual geometry and the game object has this component, right? Or this is the component that belongs to main, and then they graph all the geometry tag. Yeah, if the geometry has a geometry tag that we're gonna select all of geometry, and then we can loop through individual geometry in that list, and then send the name of function and then variable. That's it. So here, one thing I want to make sure is that all geometry has a game tag, right? And a geometry tag. Sorry, geometry. Domain is untagged, but these three objects, it belongs to geometry tag, right? This is the key. Okay, we can jump to other things because we have limited time. So I think this is also important thing for the purpose like us, like data visualization and geometry visualization. So here, okay, nothing happened. Interesting. Okay, double click it and double click the script. Oh, that's why. Okay, I'm gonna comment it out. Yeah. So you can read some of the command that I wrote. So we have two vector, and then using debug ray and debug draw ray and draw line, we can draw two different lines and then see what is different. Play. Yeah, but you know, the important thing is that only we are able to see this line on the scene view, not the camera view. The camera view is only rendered by mesh. Otherwise, we couldn't render it. It has pros and cons. This is because just imagine that every time you wanted to draw, you need to attach mesh component and material component. It's very burden, right? Just when you wanted to see so simple things for debugging purpose. So in this case, we have really good tool for the debug lay and line. Only difference is lay is starting from the first vector and then follow the second vector. This is the important difference between ray and line. And then line is simply connect two different vectors, that's it. But the ray, again, we starting from this vector. This is important things, okay? And also we have a Gizmo. So Gizmo is a special sort of the visualization entity that only rendered by in the scene view. And also we need to put this line of code inside of this particular function. Otherwise it's gonna show the errors. Yeah, I think it's not working. Yeah, you need to put the this line of code, Gizmo code, inside of this function. This is an inbuilt function. Just keep the identical name of the function. So, yeah. So we have a cylinder here, right? We have a sphere for the first vector for the ray, and the second vector of the ray is utilized for the position of this cube. Here we create a two vector, right? Also we can specify the color of the vector and then draw from here to there as a line. And then for the first vector, we're gonna populate the sphere, which is not, it has nothing to do with game object. This is just Gizmo. We can click it, but only with it will be rendered only inside of the scene view, right? And then we can mesh filter. Using the mesh filter, we can draw the mesh. Yeah. These are example. I mean, just use this example as a snippet. Whenever you want to write your own code, just visit and copy paste it. Use it. It's okay. Yeah. Yeah, we are done for the component. Do you guys have any question for the component?
Maybe just one thing. Does everybody know what the Gizmo is in Unity? Yeah. All right. So just feel free to ask.